Okay, now we're going to talk about derivatives of exponential and logarithmic functions. So first of all, an exponential function. If you remember what an exponential function looks like, it is y equals a times b to the x. Okay, so these are exponential function. And depending on what b is, remember this can either be a growth or a decay problem. That's very important. This isn't too important now, but later on, when we do applications of the derivative for exponential logarithmic functions, we'll talk about that. And also remember that all logarithmic, the reason we're doing these together is that all log functions can be written equals x. So if you have log base a of b equals x, that can be rewritten as a to the x is equal to b. So all log functions can be written as exponential, and all exponential functions can be written as log. So first of all, what we're going to do is we're going to go over each exponential logarithmic function and then find its derivative. So first of all, you have e. We've talked about e before, but e is defined as 1 plus 1 over x to the x power as x approaches infinity. So you'd have 1 plus 1 over 0, or sorry, 1 plus 1 over infinity all to the infinite power. And so this represents the rate of growth, that we've talked about in algebra, pre-calculus, stuff like that. But now we're talking about infinite growth. So something is infinitely growing means it's growing all the time. It never stops growing, hence the number e. Anyway, when you need to find e, it's really, really easy. The derivative of e to the u is e to the u times the derivative of u. So you can write that in words if you need to, but it's e to the u times the derivative of u. So first of all, identify what u is, and that's negative x over 4. Then identify what the derivative of that is, so that's du over dx, and that's just negative 1/4. So then that means that our derivative is just going to be dy over dx is e to the negative x over 4 times the derivative of our exponent, which is then negative 1/4. You can rewrite that as negative 1/4 e to the negative x over 4. And you can rewrite that, getting rid of the negative exponent, as negative 1 all over 4 e to the x over 4. Now you may not need to do that. You could probably stop at the step before that, but on the AP exam, multiple choice, you just need to be really careful because they can put any of those possible answers there, and you just need to be used to simplifying as far as you can go, because that's probably the most likely answer they'll have. So then if we look at an exponential function, a to the x, the derivative is a little trickier, but it's in 3 parts. So if you find the derivative of a to the u is a function, okay, like x squared or whatever. The derivative is 3 parts again. It's the function itself times the natural log of the base times the derivative of the exponent, which is the product of those 3 things. The function itself times the natural log of the base times the derivative of the exponent. Okay, so if we look at this, your u part is negative x, and the derivative of that is negative 1. Alright, so now your a is 9, so it's going to be then just 9 to the negative x times the natural log of your base, which is 9, times the derivative of your exponent, which is just what we have here, negative 1. And we can rewrite that as this negative 1 can come out front. This natural log of 9, that's the same as the natural log of 3 squared, which means we can bring that 2 out front, and so it would be 2 times the natural log of 3. Okay, so we're multiplying all those. And then the last thing you can do is on top you would have negative 2 ln of 3 all over 9 to the x. Get rid of that negative exponent. Simplify it as far down as possible. and then that's your answer for the derivative. Okay, so we did e to the x, we've done a to the x, and so now the next one is natural log of x. This is another pretty easy one. The natural log of u is a function, is just 1 over u times the derivative of u. So first of all, identify what your u is, and in this case that's 10 over x. And then when you find the derivative, okay, 10 over x is the same. You could do low d high minus high d low all over low low, or you could do 10 times x to the negative 1. And then when you find the derivative of that, that's you bring this down, so it's negative 10x to the negative 2, which is then negative 10 over x squared. And so that's our derivative. So the derivative of the function itself is going to be 1 over u, so it's going to be 1 over our u is the 10 over x, times our derivative of u, which is what we have here, the negative 10 over x squared. Remember, all that is then over 1. Alright, so when you simplify this, you bring this 10 over x, you're going to take this and bring it up top, it becomes x over 10. So you'd have x over 10 times negative 10 over x squared. And here's where you can simplify some things, like this x disappears, becomes a 1, and this becomes an x to the first, this becomes a negative 1, and this becomes a 1. So you're left with then just negative 1 over x. And then that's our derivative. Okay, so that's for the natural log function. Wrong way. There we go. Next one we're going to do is for your logarithmic function. So that's log base a of x, and it's where the x is. This is where your function is going to be, like x squared or sine of x or whatever. And u has to be greater than 0. It can be any value, like in this case it's 2. But this one's tricky. You can't just do this straight up like this identity here. Okay. First thing you have to do is let's rewrite this, because this is the same as log base 2 of x to the negative first. Now you can see that we're going to have to use a chain rule as well as the derivative of log rule up here. So the first thing we're going to do is identify your u. In this case, u is x. And then the derivative of u is just 1. Simple enough. So now let's look at this rule up here. So the derivative of our log function, looking down here, you have to do the chain rule first. Oops, didn't mean to do that. So it's going to be negative 1 times the derivative, or times the inside. Subtract 1 from your exponent. Then times the derivative of the inside. So this is where you use the log rule. So it's going to be 1 over our u is x times the natural log of a, which in this case a was 2. All that times the derivative of u, which was 1. So if we rewrite this, okay, you have this negative out front, so that makes it negative overall. And also this negative 2 takes this log function down, so it's going to be log base 2 of x, quantity squared, and then you would have times x times natural log of 2. Like that. And then you would have to put, there's nothing other than a 1 on top, so you'd have to put that. There's no negative exponents. You can't simplify any of this. And so we are done. And you can't change this to 2 times because it's x squared. It's not x squared, it's the quantity squared, so that's a little different. Okay, so that's as far as we can go for that one. And so that's all the derivatives that we have. You have here the log. It's mostly just knowing the rules and being able to use the rules to find derivatives. So I just have one example of each. You can ask me in class if you want more examples. There's examples in your homework. Or if you want me to clarify on any of these, ask me in class. But we have the derivative of log, the derivative of natural log, the derivative of an exponential or a to the x function, and then e. So again, they're not that difficult, but you do need to memorize them and to know them for your quizzes, tests, exams, all that stuff. Okay, on this last problem, let's take a look at a picture to try to understand what's going on. So you're looking for a point that goes right here through the origin. And so this line that goes through the origin touches or is tangent to this graph somewhere and has a slope of m, but we don't know what that slope is other than m. Okay, so the first thing, let's go ahead and find the derivative of this line. So that'd be dy over dx is equal to, you do 1 over u, so that's 1 over x over 3 times the derivative of x over 3, which is 1/3. And so reciprocate the x over 3, that becomes 3 over x times 1 over 3. And then simplify, and you would get 1 over x. So this means, this gives you the slope at any point on your function. Okay? So now what we do is we know that this line passes through the origin, and so then that is the point 0, 0. So let's come up with the equation for that tangent line. Or not necessarily the equation for that tangent line, but using this slope of 1 over 0, you could write y equals 1 over x times x minus 0 plus 0. And then when you do all of this, this simplifies simply that y equals 1. So that tells you where it touches this graph. So over here, at y equals 1, so at about right here, that's where this tangent line is going to touch that graph. Okay? So now we know, I know this is tricky, but try to follow along. We know that the slope at any point is equal to 1 over x. A roundabout way of finding x, because we need to figure out what this is at exactly what point. So a roundabout way of finding this is take your equation and solve for x. So you take e to each side, gets rid of the natural log, and you just have x over 3. And then multiply each side by 3. And so it's 3 e to the y, that's equal to x. And we can plug that in down here. So it's 1 over 3 e to the y. But we also, from this equation, we know that y is equivalent to 1. So then the equation for our slope is 1 over 3 e to the first. And they wanted an actual value. That's the tricky part, is they wanted an actual value. That's why we had to do all of this roundabout stuff, do a lot of circles to come back to here. So the actual value for the slope is 1 over 3 e to the first, or 1 over 3 e to the negative first, either one. But like I said, this is simplified since this doesn't have the negative.